Good day, everyone. So today our topic is belt and chain drives. We shall be exploring the fundamental mechanism of power transmission using these two drives. In this topic, we'll be looking at the definition of these two drives, their types, as well as their uses. So let's dive into this. Um, let's start with the first one, that's the belt drive. A belt drive is actually a flexible loop strip that link rotating shafts, as you can see here. So this is a flexible loop strip, okay? And it links two rotating shafts together, thereby transmitting power from one to the other. Usually, the smaller shaft is the driving shaft, while the bigger shaft is the driven shaft. So the smaller one drives the bigger one, just to reduce speed. All right. So the essence of belt drive or drive generally is to transmit power from one point to the other. All right. So the belt drive also come in different types. We have the flat belt, as you can see it here. This is the simpler type of belt drive, and usually the belt is usually leather or rubber. So this black belt here is either a rubber or a leather, and it's usually coated with fabrics. So it relies on the friction between the belt itself and the surface of the sheath. The sheath now is the rotating shaft itself. Okay, so it connects both the bigger sheath with the smaller sheath together. And the major thing is that it is made up of the belt is made up of either rubber or leather. All right, and it is smooth. Okay, it's a smooth belt. That is the first type of belt. We have the flat belt. We also have the synchronous belt, or sometimes called the timing belt. The timing belt is different from the flat belt in the sense that it has teeth. Look at it here. You can see that this belt has teeth, and this teeth is made to mate with the sprocket or the sprocket of the rotating shaft. Okay, it is made to interlock with it or mate with it, as you see here. That's what makes it different from the flat belt. It has teeth, which helps in mating with the groove of the sprocket. And with this connection, it helps in positive drive. So sometimes we refer to it as positive drive because it made the driving better than in a flat belt. In this case, the belt is more firm, is firmer on the groove of the sprocket or the rotating shaft than the flat belt. And the third type of belt we have is referred to as the cork belt. The cork belt, so we just like the synchronous belt because it also has teeth. The only difference is that it is more flexible and efficient. That's one. Second thing is that it's usually applied to a V groove shift. Okay, so whenever the groove are in form of V shape, that's when you make use of the cork belt. You see now, this is a cork belt because one, it has teeth that helps in grabbing or in gripping the groove of the sheath, and also number two, it is efficient and flexible compared to the standard belt like the flat belt. And the last type of belt that we have is called the V belt drive. The V belt drive is just almost in the same design with the cork belt, okay, but it's just that the V belt can either make use of a timing belt, okay, or a flat belt, in as much as in form of a V shape. All right, in as much as the two shifts, when I say shifts now, I mean the rotating shaft, in as much as the two of them are in V shape, then we refer to that belt as V belt drive. So majorly, these are the four types of belt drive that we have. As we have said earlier, drive, whether belt or chain, are usually used to transmit power from one point to another point in the machine. So then, we also have what we call the arrangement of belts in a machine, belt and pulley arrangement. There are two major ways you can arrange belts in a pulley system. The first one is called the open belt arrangement. In this type of arrangement, you connect two pulleys or two shafts to make them run in the same direction. As you see here, the first one here is called the open belt. So in this case, the two pulleys are moving in the same direction. In my own case, and they are both moving in anti-clockwise direction. The bigger pulley is moving in anti-clockwise direction. Same way with the smaller pulleys moving in anti-clockwise direction due to the belt connected to it. So whenever you have this kind of belt making the pulley to move in the same direction, you refer to it as open belt. But on the other hand, when you have cross belt, in this case, there is change in direction of rotation between the pulleys. Okay, as you can see here, this is an example of cross belt. The first one here, the first pulley is moving in anti-clockwise direction, you can see. But the second one is moving in clockwise direction. So they are moving in opposite direction due to the crossing of the belt. So these are the two major ways that belt and pulley are arranged in automotive machine. All right. Now, can we now talk about the chain drive? I haven't known what the belt drive is. Now, the chain drive is far better than the belt drive. It's a robust power transmission. The chain drive transmits more power than the belt drive. So how does it achieve this? The chains are pin connected links. As you could see here, so these are the links here. They are pin connected. This one pin, another pin, another pin. So they are pin connected links that are used for transmitting large tensile force. Okay, they are used for transmitting large tensile force or for transmitting power generally. So with this pin engage with the teeth of the shaft. Okay, and in that case, it gives a firmer connection with the shaft than the belt drive, and help in transmitting higher power than that of the belt drive. Okay, so just that we have types of belt drive, we also have different types of chain drive. Okay, now what are the components of the chain drive? It consists of the chain itself, and then the sprocket that is connected with the chain, and then the rotation begins to lead to transmission from one sprocket to the other. Let's consider the types now. The first one here is called the roller chain drive. You can see the chain here. Okay, the chain here is moving as the sprocket is moving, driven by transmitting power from the bigger sprocket to the smaller, from the smaller sprocket rather to the bigger sprocket, because usually the smaller sprocket is the one that drives the chain. So why is it called the roller chain? In the chain, you have a roller, all right? You have a roller, you could see something like this in vertical form. They are actually rotating. So as they are rotating, they are driving the sprocket, okay? So the rotation of the rollers in the chain is what leads to the rotation of the sprocket, okay? So it's the most common type of chain drive, the roller drive, the roller chain drive, okay? And then for standard roller chain drive, it's ranging between 40 to 240. Now, the roller chain features roller on each pin. The pin connecting the sprocket reduces friction. All right, because as it's rolling now, you know when there is When something is rolling, friction is reduced. And when friction is reduced, the power is transmitted more. No friction opposes motion. That's one good thing, and that's what makes the chain drive far better than that of the belt drive. So the first one is called the roller chain drive. We also have the conveyor chain drive. The conveyor chain drive is also made up of pin, just like that of the roller chain drive. But the only difference is that the rollers in conveyor chain drive sit proud of links. In other words, the links of the rollers in conveyor chain drive protrude out, okay, of the pins, thereby helping in conveying materials. You see that these materials are being conveyed due to what? Due to the conveyor chain. These objects are moving on the conveyor chain because of the way the rollers are being designed on it. They sit proud of links between the pins. So they are majorly used for transporting materials as rollers can support weight. Okay, so the roller can support weight of any object placed on it as it moves. Okay, and can also support the chain weight. When the rollers are connected together they form a weight. So they can support the chain weight itself as a total, as a complete chain. All right. So we have just talked about the conveyor chain and how it works, majorly for transporting materials through the rollers on the chain. And then we have what we call the inverted tooth chain, or sometimes referred to as the silent chain. In this chain, the chain has it has a link. Okay, the chain has a link. You could see in form of teeth. Okay, so with these teeth now, it's able to mate with the sprocket, and when it's able to mate with the sprocket, it will be firmer on the sprocket, and the transmission will be higher than when there is no teeth. Unlike the rollers chain or the conveyor chain, where we do not have this type of design, or where we have rollers. So in this case, this shaped link is replacing the rollers, and with this is able to mate better on the sprocket, like you see here, and then there is better transmission of power. Okay, so we use this link instead of rollers, and then movement occurs by rolling instead of sliding. If it were roller that were there, it would be sliding around the sprocket. But now, because of the fact that it is a shaped link, it's going to be rolling, right? So this inverted tooth just look like gear teeth as well. Okay, gears are made up of teeth. So just the way gears have been designed, that's the way the teeth of inverted tooth chain are also designed. See, so that as they move, they mate with the grooves of the sprocket. Okay, so I want to talk about that. Let's also talk about the lift chains or lifting chains. The lifting chain or lift chain is designed specifically for lifting applications rather than power transmission. The other two that we have mentioned are usually for power transmission, but for this one, this lift chain is basically for the lifting of application. They do not make with sprocket. Okay, let's go see this. This is a diagram of a lift chain. There is no way they can match with sprocket because they do not have any roller, neither is there any shaped link that can make them mesh with sprocket. So they are basically used for lifting load, for lifting application. All right, and this design makes them narrower than roller chain. So they are more narrow than roller chain because they do not have rollers, neither do they have any shape link. All right, so what have we learned today? Number one, we've learned belt drives, that they are flexible and used for transmitting power smoothly. Okay. Number two, we learned about chain drive, that they transmit robust power than that of belt drive using pin connected links, just like the rollers and the link, the shape link. Okay, and then we talk about their types. We have the roller chain, we have the conveyor chain, we have the inverted twist chain. Just like we have different types of belt drive too, flat, the timing, and the V belt. So, where can these two be applied? They can both be applied in industries where they make use of industrial machines and automotive machines, and for also transmission of power. All right. So I will be drawing my curtain here today. I hope you have learned something on belt drive and chain drive. Thank you for watching and have a wonderful day. Bye for now.